Hey, let's continue our discussion, guys. So now we have to understand the port ID. In previous lecture, we understand how port ID is also going to be play a significant role while selecting the any other root port and designated port. And also we understand the port level, means the port number, that gigabyte 0 by 0, gigabyte 0 by 1, how it is going to play. Lower number is going to become the forwarding port, that is the designated port, or might be the root port as well. So this port ID is very important. Port ID is the unique identifier for the STP that is going to be used when you're just going to configure the configuration in the STP. So you have to give the port number, which is going to be with the port priority and the port number. So this port priority is going to be like this one, and based on that port priority, you are going to just configure your all kind of the STP process. So you can see in this particular topology, we have the different port ID, and this switch having a different port. But this port priority is going to belong from 1 to 22, and interface number is going to be like this, gig by 0 by 0 or gig 0 by 1, this port number. So lower priority is going to win your selection process. If priority is going to be same, then lower port ID is going to win your selection process. So use the tiebreaker during the root port selection, designated port selections, and that is going to help to decide which port win to when everything else is going to be equal. Means it's going to help to tiebreaker. So this port ID is going to in two combination based on the port priority and the port number. If port priority is going to be same, then your port number is going to be act as a tiebreaker. Means this is like gig 0 by 0 or gig 0 by 1. So when does it going to use the port ID? When root path is going to be same. In previous lecture we understand when both path we have the same cost, then it is going to act as a tiebreaker. And in the situation when we have this kind of a topology, means we have the switch 1, we have the switch 2, and they have the same cost with a multiple link, then this priority is going to be there. If you have the different topology, then normal your closest, whatever the neighbor having a lower priority, that is going to win the selections. So I hope you guys understand. Now moving forward, apart from that, we have the different STP stage. Means if you talk about the legacy STP process, we have the learning, we have the listening, we have the forwarding, and we have the disable and blocking stage. So whenever the STP is going to run between the switches, these stages are going to be happen. Means by default, the port is going to be in block stage, then it's going to be listening, then it's going to be learning, and then it's going to be forwarding state, and sometime it is going to be disable state as well. So disable is going to be very first, but blocking and learning, listening is going to be your like other stage. So you can see we have the disable port, we have the learning, listening, and the forwarding port. So what is going to happen when this is disabled? This is the very first stage. Means what is going to happen in this situation? Port is might be administrative down. Means there is no frame is going to forward it. Means everything. Let's suppose switch you branded, switch you purchased from the market or my Cisco, your switch port is administratively down. That is known as a disable stage. But this means the port does not participate in the STP selection process because you make the admin down. But when you make the no shut, that means what is going to happen? There is a listening and learning port is going to be coming into picture. Blocking is going to be a little bit later. How blocking is going to come into picture? But blocking means the port is blocked. This port is the alternate path for the STP path calculations. Means if we have the switch like this way, switch 1, and this is going to connect the switch 2, this is going to connect with switch 3. So one port is going to be act as a blocking port. This is the BLK port. So this point of view, switch is going to communicate this one, this is going to communicate this one, but this port is going to down, then this blocking is going to become as a normal port, forwarding or designated, and it start going to transfer the traffic to the particular root bridge. So this is how it is going to happen. So blocking the port act as the alternate path, means if forwarding port is going to be down, then it is going to come in picture. It is going to only receive the BPDU, keep track the link and the neighboring switch's status. Means if it is blocking, it doesn't means it is not going to process the BPDU. BPDU are discussed in later stage, that is known as the bridge protocol data unit, right? So this is a very significant role in the STP. So that means even I'm in the block, in disable stage, there is no BPDU is going to process because the port is admin down. But if you are in the blocking stage, still your BPDU is going to process, and BPDU is going to be just listen where it's going to check whether my neighbor switch is stable, up and working or not. If it is not up and working, probably it is going to make as a forwarding port, either designated or the root port. Basically, it's going to be designated port. Not blocking port is always going to be designated port, never the root port. Now, listening. Still in listening, there is no frame forwarding is going to happen. Means frame MAC learning. This is nothing is going to happen in the disable stage. 100% blocking, no frame forwarding. Listening, no frame forwarding, no MAC learning. It will take 15 seconds. It's known as the transitory state. That means the port transmit and receive the BPDU to determine the STP role. Means the port is going to exchange the BPDU from one switch to another switch, and it's going to understand what is my exact role. Am I RP? Am I DP? Am I blocking port? So this role is going to be identified, right? So the port doesn't forward the traffic and learn the MAC address. This is not going to forward and learn. Based on the BPDU, it is going to understand what is my role of the port. Then after, what is going to happen? They go in the learning stage. Still, there is no frame forwarding happening in the learning state, but they start learning the MAC address. Means again, it will wait for the status for the STP is going to 15 seconds in the listening, the 15 seconds in the forwarding stage, means the learning stage. But in this process, your MAC is going to be learned. The port role has been determined. Means in the learning state, it's going to be decided whether you are the root port, designated port, or block port. Based on that, the port prepared to participate in the frame forwarding. Means the port is going to be ready to participate in frame forwarding, and in this case, they populate the MAC address table. Means the both side MAC address is going to be populated, and then finally you reach in the forwarding state where your frames, your layer 2 frames like MAC table is going to be forwarded. This is the part of the loop-free topology, and it's forward the traffic from the source to destination. That's BPDU is going to start exchanging. So by default, how much seconds you're going to take to reach from the blocking, forwarding to learning this? So it's by default, when you're going to learn the STP, it's take the 50 seconds to forward the frame. It's very slow in STP. So STP is very slow. That's why we have the new protocol. It's the RSTP. This is the rapid spanning tree protocol. So generally in latest all the switch environment, we are not going to find any STP configuration. But for the interview point of view, for learning point of view, for concept point of view, you must know STP port state, that is a disable, blocking, learning, listening, and the forwarding. And this is going to take 50 seconds time to process any frame traffic to just from disable port to the forwarding states. That's going to take 50 seconds. So I hope you understand this all concept. And default conversion time you can see here, it's a 50 seconds. We got 20, 50, 15, 15. All right. Now we have to move in the further discussion. Now in STP, we have the timers. So there are the timers. When you're going to run the STP, we have the hello timers, we have the forward delay, and we have the maxes time. Means every 2 seconds, you're going to exchange the BPDU, right? And if you're not going to get the any kind of the BPDU from the after 20 seconds, they are going to be understand you are down, right? And forwarding delay is going to be like you have to forward the frames after 15 seconds of all the convergence. So this is how it is going to be happen, and used to control the BPDU exchange and convergence. These parameters are going to be very important. Hello timer 22 seconds, forwarding delay 15 seconds, max size is the 20 seconds. Means every conversation is going to be happen on the based on this particular control. Now path cost, we understand determine the base path route cost like based on the bandwidth, how the bandwidth faster than 19, we have the gigabit like 4, and lower total cost is preferred on the path. That means we already discussed how the path cost is going to happen. Timer we already know, hello timer, forward delay, and maximum age is going to be 20 seconds. Now we have to understand type of the STP. Like we have the multiple type of the STP. As I said, very first STP is our STP 802.1D. This is our old STP. This is the very slow, because it take the 50 seconds convergence to send the frame. But there is an upgraded version as well available in the market, and that is known as the RSTP, which is known as the rapid spanning tree protocol. This version is basically defined under standard 802.1w. This is for the faster convergence. Means you don't have to wait 50 seconds. It's going to forward frame immediately. And also we have the concept PBST plus. This is for the Cisco proprietary, but it is going to run the STP process. Means this is only going to learn the Cisco switches, and this is only for the Cisco proprietary. Means if you want to learn the VLANs in the Cisco and you want to run the PBST, it is going to work in the Cisco. And that means if the 100 VLANs, you can run the 100 of the instances for the spanning tree protocols. And this is the PBST. Rapid PBST, again Cisco, but it's going to be faster than PBST. And there is the MSTP as well, that is known as the multi-span tree protocol. This MSTP is also very important for the group of the VLAN. If you want to run and you want to make the communication based on the group of VLAN, this is going to help on the run the protocol from the group of the VLAN. So let me summarize. STP is the older version, RSTP is the faster version, latest version, but these are the open standard. You can run anywhere of the switches. PBST, it's the older version of the Cisco where you can run the per VLAN spanning tree. But if you are going to run rapid PBST, is Cisco very faster PBST protocol for the per VLAN. MSTP, if you have the 100 VLANs, you want to run 50 VLAN, one group of the instance, 50 another VLAN, one group of instance, you can run the MSTP, right? That's why you can see in spanning tree protocol, we have the MSTP original, the MSTP, STP, RSTP, and then RSTP, that is the original one, IEEE, and this PBST Cisco proprietary, and this is the IEEE for the standard, the MSTP basically 802.1s. So you should know these all basic fundamental of the STP because these are the very important as well sometimes. So I hope type of spanning tree you also understand about that, right? Now let me do the deep dive about the spanning tree protocol in the next lecture so you guys can understand in very details. Thank you so much.